Yes, subpanel can be located in a walk-in closet, provided that sufficient access and working space can be maintained according to the applicable electrical codes. The National Electrical Code, or NEC, provides specific guidelines for the installation and location of electrical panels, including subpanels. These guidelines are primarily concerned with safety and accessibility. Firstly, consider the working space requirements. The NEC mandates a certain amount of clear space in front of electrical equipment, including subpanels, to allow for safe operation and maintenance. This working space typically includes a minimum depth, width, and height. The specific dimensions of the required working space depend on the voltage of the equipment and the conditions of the surrounding environment, such as whether the equipment is exposed to energized parts on one or both sides. Secondly, ensure adequate access. The subpanel must be readily accessible, meaning that it should be easily reached without having to climb over or remove obstacles. The path to the subpanel should be clear and unobstructed. In a walk-in closet, this might mean ensuring that clothing or other stored items do not block access to the panel. Thirdly, think about the environment. The location should be dry and well ventilated. Avoid areas where the subpanel could be exposed to moisture, corrosive fumes, or extreme temperatures. Walk-in closets are generally dry spaces, but it is still important to verify that there are no potential sources of moisture, such as plumbing leaks. Fourthly, consider dedicated electrical space. The space above and below the subpanel should be dedicated to electrical equipment. This means that you should not store anything in these areas that could interfere with the panel's operation or maintenance. The NEC typically requires a certain amount of clear space above and below electrical panels. Fifthly, check for proper illumination. Adequate lighting is essential for safe operation and maintenance of the subpanel. The area around the subpanel should be well lit, so that you can clearly see the panel's components and markings. Sixthly, ensure proper labeling. All circuits in the subpanel must be clearly labeled to indicate their purpose. This helps to prevent confusion and makes it easier to identify and troubleshoot problems. The label should be legible and durable. Seventhly, ground the subpanel correctly. Proper grounding is essential for electrical safety. The subpanel must be properly grounded to the main electrical service. This helps to prevent electrical shock and reduces the risk of fire. Eighthly, use appropriate wiring methods. All wiring to the subpanel must be installed in accordance with the NEC. This includes using the correct type and size of wire, as well as proper conduit and fittings. Ninthly, consider the voltage drop. The voltage drop from the main panel to the subpanel should be kept to a minimum. Excessive voltage drop can cause equipment to malfunction and can even damage electrical components. Tenthly, follow local codes and regulations. In addition to the NEC, there may be local electrical codes and regulations that apply to the installation of subpanels. It is important to check with your local electrical inspector to ensure that you are in compliance with all applicable requirements. 11thly, consider professional installation. Unless you are a qualified electrician, it is best to have a subpanel installed by a professional. A qualified electrician will have the knowledge and experience to ensure that the subpanel is installed safely and correctly. 12thly, regarding specific NEC articles. NEC Article 110.26 covers the requirements for working space around electrical equipment operating at 600 volts nominal or less. It specifies the minimum depth of the working space, which depends on the voltage to ground and the presence of exposed live parts. For example, for equipment operating at 150 volts to ground, the minimum depth of the working space is typically 3 feet. NEC Article 312.5 covers the requirements for cabinets, cutouts boxes, and meter socket enclosures. It specifies the minimum size of the enclosure and the requirements for wiring and grounding. NEC Article 408.3 covers the requirements for switchboards and panel boards. It specifies the requirements for the location, installation, and wiring of these devices. NEC Article 408.38 covers the requirements for overcurrent protection. It specifies the type and size of overcurrent protection devices that must be used to protect the subpanel and its circuits. 13thly, clarify about dedicated equipment space. NEC Section 110.26. E addresses dedicated equipment space, stating that the space equal to the width and depth of the equipment and extending from the floor to a height of 6 feet above the equipment or to the structural ceiling, whichever is lower, shall be dedicated to the electrical installation. No piping, ductwork, or other equipment foreign to the electrical installation shall be located in this zone. 14thly, understand the importance of clear access. The requirement for clear access means that the working space in front of the subpanel must be kept clear of obstructions. This includes items such as clothing, boxes, and furniture. The access path to the subpanel must also be clear and unobstructed. 15thly, think about panel board requirements. Panel boards must be suitable for the environment in which they are installed. If the subpanel is located in a damp or wet location, it must be enclosed in a waterproof enclosure. Panel boards must also be protected from physical damage. If the subpanel is located in an area where it could be damaged by impact, it must be protected by a barrier or enclosure. 16thly, regarding circuit identification. Each circuit in the subpanel must be clearly identified with a label that indicates its purpose. The labels must be legible and durable. The circuit directory must be updated whenever circuits are added or removed. 17thly, clarify grounding requirements. The subpanel must be properly grounded to the main electrical service. This is typically accomplished by connecting a grounding electrode conductor from the subpanel to a grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode conductor must be sized in accordance with the NEC. 18thly, follow wiring methods and materials. All wiring to the subpanel must be installed in accordance with the NEC. This includes using the correct type and size of wire, as well as proper conduit and fittings. The wiring must be protected from physical damage. 19thly, confirm overcurrent protection. Each circuit in the subpanel must be protected by an overcurrent protection device, such as a circuit breaker or a fuse. The overcurrent protection device must be sized to protect the circuit from overload and short circuit conditions. 20thly, voltage drop is important to consider. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the beginning of the circuit. Excessive voltage drop can cause equipment to malfunction and can even damage electrical components. The NEC recommends that voltage drop be limited to 3% for branch circuits and 5% for feeders. 21stly, remember about inspections. Electrical inspections are typically required for new electrical installations, as well as for alterations and additions to existing installations. The electrical inspector will verify that the installation complies with the NEC and local electrical codes. 22ndly, clarify about load calculations. Before installing a subpanel, it is important to perform a load calculation to determine the size of the subpanel and the size of the feeder conductors. The load calculation must take into account all of the loads that will be served by the subpanel. 23rdly, consider the physical size of the panel. The physical size of the subpanel should be appropriate for the location in which it is installed. The subpanel should not be too large or too small for the available space. 24thly, consider any future expansion. When installing a subpanel, it is important to consider any future expansion that may be needed. The subpanel should have enough spare capacity to accommodate any additional circuits that may be added in the future. 25thly, remember about the importance of safety. Electrical work can be dangerous. It is important to take all necessary safety precautions when working with electricity. Always disconnect the power before working on electrical circuits. Wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not qualified to perform electrical work, hire a qualified electrician. 26thly, when assessing the walk-in closet, consider the layout. The layout of the walk-in closet should allow for easy access to the subpanel. The subpanel should not be located in an area where it is difficult to reach. 27thly, you must be careful of storage practices. Storage practices in a walk-in closet should not obstruct access to the subpanel. Clothing, boxes, and other items should be stored in a way that does not block the subpanel. 28thly, you must think about the maintenance tasks. Routine maintenance tasks such as checking circuit breakers and replacing fuses should be easy to perform. The subpanel should be located in an area where it is easy to work on. 29thly, consider any potential hazards. Potential hazards, such as water leaks and flammable materials, should be addressed before installing the subpanel. The subpanel should not be located in an area where it could be exposed to these hazards. 30thly, regarding local building codes. Local building codes may have specific requirements for the installation of subpanels. It is important to check with your local building department to ensure that you are in compliance with all applicable requirements. In summary, while technically permissible to install a subpanel in a walk-in closet in Minnesota, adherence to NEC guidelines and local codes is paramount, ensuring safety, accessibility, and proper functionality.